So sorry for the interruption, small interruption. That is the reason I couldn't able to continue. That is the reason I disconnected and connecting once again. So in the previous now we are discussing the Ohm's law. Ohm's law. Ohm's law is nothing but the potential difference across the ends of the given metallic conductor the potential difference across the ends of the given metallic conductor V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. At a constant temperature. So very important point is at a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. So that is about Ohm's law. Coming to the materials required. So what are the materials required? Now I will discuss materials required. Materials required. Okay, materials required. First one you have to take nichrome. 4 cells you have to consider. 4 cells. Those are here 1.5 volts each. So each cell is 1.5 volts each. First one is 4 cells. 4 cells. Each cell is 1.5 volts each. 1.5 volts of each cell. Or 1.5 volts of each. If you are taking like this also, instead of that 1.5 volts of each. Right? And coming to the second one, nichrome wire. Nichrome wire is an ally of nichrome wire. Nichrome wire. Okay, nichrome wire, so 0.5 meter length. And coming to third one, nichrome wire is an ally of nickel, chromium, manganese and iron metals. Nichrome wire is an ally of nickel, chromium, manganese and iron metals. Okay, now ammeter, and coming to the fourth one, voltmeter, and coming to fifth one is switch, and sixth one is connecting wires. Okay, so once again, 4 cells 1.5 volts each, 4 cells 1.5 volts each. Nichrome wire is an ally of nickel, chromium, manganese and iron metals. So that is 0.5 meter length. Ammeter, voltmeter, switch. So we can also say this is key. And connecting wires, right? Yes. So first you have to take the procedure. Procedure is procedure. Procedure. First one is connect one cell. Connect one cell and note down the reading of ammeter and voltmeter. Connect one cell. Connect one cell and note down the reading of ammeter and voltmeter. Next, connect two cells. Connect two cells. Again, note down the reading of ammeter and voltmeter. Ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Repeat the process for 3 and 4. And mention the values in the tabular form given below. Okay, I will draw the tabular form once again. First you have to connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. Repeat the process for 3 and 4. Right? And draw the and mention the values in the tabular form. So I will draw the tabular form. Just check once. So I am drawing the tabular form. This is the tabular form. You can check once here. So serial number, number of cells, ammeter reading, voltmeter reading, V by I form, that is R. Okay, 1, 2, 3, 4, 1, 2, 3, 4. So 4 cells I am taking. 4 cells I have to, so 4 cells I have to take. Okay, one cell, connect one cell and note down the reading of ammeter and voltmeter. Connect two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4 and mention in the tabular form given below and draw the graph for VI. Okay, so V on Y axis, I on X axis. Once again, V on Y axis, I on X axis. Okay, so if you draw that graph, the graph shows linear. Okay, starting from origin. So this is for ohmic conductor. This is for ohmic conductor. The substances which obey Ohm's law, those are called ohmic conductors. The conductor which obey Ohm's law, those are called ohmic conductors. Ohmic conductors. Okay. Coming to non-ohmic conductors, the graph is curve. The graph is curve. So you can see here. The graph is curve. Okay. So like this. That is for non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductors. Ohmic conductor means the conductor which obey Ohm's law, those are called ohmic conductor. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. I hope it is very clear about it. So this is about Ohm's law. So the potential difference across the ends of the metallic conductor is directly proportional to current flowing through it at constant temperature. At constant temperature, very very important. So V is directly proportional to V equal to IR. Metals required 4 cells, 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each. Like that 4 cells I am taking. And nichrome wire is an alloy of nickel, chromium, manganese and iron metals. So that nichrome wire is length is 0.5 meter. Okay. and ammeter, voltmeter, switch, and connecting wires. Okay, connecting wires. So I hope it is very clear about it. So this is about Ohm's law. Next one, we will discuss about resistance and resistivity. Resistance and resistivity will discuss. So very important, resistance and resistivity. So related to that we will discuss, and problems also will come based on this one, based on resistance and resistivity. Resistance and resistivity will discuss now. Resistance and resistivity. Okay, resistance. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the cross section. So R equal to L by A. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. So here, so SI unit of resistivity is very important. SI unit of resistivity. So now we are discussing R is resistance. Okay. R is a resistance. And rho is a resistivity. R is resistance, rho is resistivity. Okay, so rho equal to RA by L. RA by L. What is SI unit of resistance? SI unit of resistance ohm. SI unit of area is meter square. SI unit of length is meter. Meter get cancelled. Then ohm meter. So resistivity is equal to ohm meter. Okay, so definitely 1 mark will come for this. Okay, so 1 mark will one mark question will come on this one. So that is related to SI unit of resistivity, and derivation is very important, 2 marks. So derivation they will ask for 2 marks, and the relation between resistance and resistivity 1 mark also. So derivation of what? Derivation of SI unit of resistivity, SI unit of resistivity, derivation they will ask for 2 marks, for 2 marks, and 1 mark SI unit of resistivity they will ask. Anyway, SI unit of resistance is ohm, okay, and relation also they will ask between resistance and resistivity. Now, difference between resistance and resistivity, very, very important. Difference between resistance and resistivity. Definitely they will ask for 3 marks question also. And based on that one, many questions are there. Many questions are there. I will explain those questions. Check once here. Many questions related to resistance and resistivity. Okay, I'll explain. Okay, done. Difference between resistance and resistivity we'll discuss now. Difference between resistance and resistivity. Resistance. Resistance and resistivity. So first point is, anyway, definition anyways, it's very important definition. Okay. Resistance. R equal to rho into L by A. Here first point, rho equal to RA by L. Second one, SI unit of resistance is ohm. Ohm meter. And coming to third one, symbol, third one. And coming to fourth one, resistance depends on length and area. Depends on. Coming to fourth one, so does not depend on length and area. Does not depend on length and area. Okay, so it does not depend. Does not depend on length and area. Fifth one, resistance depends on temperature. And here fifth one, resistivity also depends on temperature. And coming to sixth one, material. And here also metal of the conductor. Okay. So resistance depends. So this is the formula. So very, very important. So based on this one, definitely many questions will come on this one. So factors related to resistivity. So formula, SI unit, symbol, and factors. Depending factor does not depend factor. So it does not depend on length and area. Here resistance, SI unit of resistance, symbol, and here I am taking factors, and here temperature and material. Okay. So resistance depends on temperature, resistance depends on material of the conductor. So I hope it is very clear to you all. Next one we will discuss about resistors are connected in series combination, resistors are connected in parallel combination. So we'll discuss those points. Resistors are connected in series combination, resistors are connected in parallel combination. Resistors are connected in series combination, resistors are connected in parallel combination. We'll discuss now. Resistors are connected in series combination. Next, resistors are connected in parallel combination. First, we will discuss about resistors are connected in series combination. Okay. Now, resistors are connected in series combination. So here is R1, not? So here this one is R1 and this one is P1, V2. Okay. Now from Ohm's law, V equal to IR. From Ohm's law, we know the Ohm's law. V equal to IR, right? So across, so if you see throughout the circuit, current is same. Throughout the circuit, current is same. So through R1, R2, R3, current is same. That's why. So I'm taking the resistors are connected in series combination. Resistors are connected in series combination. So that's why Is equal to I1 equal to I2 equal to I3 equal to I. So I'm taking the current. Okay. So current is same. Current is same throughout the all the resistors. Through R1, R2, R3, current is same. Okay, done. Fine. Now, potential difference is different, right? So across R1, V1, across R2, V2, across R3, V3. So different potential difference is there. Yes or no? Potential difference is different. So in that case, we can write Vs equal to V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3. Sir, you are taking V equal to IR. So same we can take here also, right? Because so current is same. So throughout the circuit current is same. So that we can take I. Is, IV, Is equal to I1 equal to I2 equal to I3 equal to I we can take, right? So I am taking IR1 plus IR2 plus IR3. Shall I take I common? I am taking I common. Rs equal to I if you are taking R1 plus R2 plus R3. So I get cancelled. So I am cancelling I value. Then remaining answer is Rs equal to R1 plus R2 plus R3. Yes or no? Rs equal to R1 plus R2 plus R3. So that is the formula. That's enough. So listen carefully. R1, R2, R3 are connected in series combination. So Is equal to I1 equal to I2 equal to I3 equal to I. Sir, why current is same? So throughout the circuit, because whatever the potential difference, whatever the battery is added to this one, so that current will pass through R1, R2, R3. Okay, same current will reach. That is the reason current is same throughout the circuit. And here one point is very important. When we are comparing series and parallel, that time also I will tell, but still I will tell here. If among these three resistors, suppose if you take a bulb 1, 2, 3, if one bulb is fused off, if one bulb is fused off, if one bulb is not working, so remaining bulbs it won't work. Okay, so that is a disadvantage. There is a disadvantage of the series combination. That is the reason we are not using series combination in the household. We will use parallel combination. So when I am explaining the parallel combination, that time I will explain about parallel combination. Okay, now we are discussing about series combination, right? So here, Zarya, okay, fine. If I connect n number of resistors, you connected only three only, sir. You connected only three. If I connect n number of resistors, what is the formula? If I connect n number of resistors, what is the formula? The formula is Rs equal to Nr. Rs equal to Nr. This is the formula. Rs equal to Nr. So normally Rs equal to R1 plus R2 plus R3. So I am taking only 3 resistors. That's why I am taking here. If n number of resistors are connected in series combination, Rs equal to Nr. Okay, so this is the formula. If I connect resistors are in parallel combination, so what is that? So now I will explain. Check once. If resistors are connected in parallel combination, So what happens if resistors are connected in parallel combination? Now you can see here. Okay, now you can see here. Resistors are connected in parallel combination. Resistors are connected in parallel combination. R1, R2, R3, three are resistors connected in parallel combination. Current is passing. Ammeter and voltmeter. Voltmeter is connected across R1, R2, R3 because potential difference is same across R1, R2, R3. From Ohm's law, V equal to IR. From Ohm's law, V equal to IR we can take. V equal to IR. And I equal to V by R. From Ohm's law, V equal to IR, I equal to V by R. I equal to V by R. Right? Yes. Here, okay, done. V equal to IR, I equal to V by R. Right? Yes. Now we can see here. IP equal to I1 plus I2 plus I3. IP equal to I1 plus I2 plus I3. Okay. Current is different. Even though potential difference is same, current is different, right? That's why I'm taking IP equal to I1 plus I2 plus I3. That is nothing but we can write V by RP. V by RP we can write V by RP equal to V by R1 plus V by R2 plus V by R3. So we can take common V by 1 by RP equal to V am taking 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so V we get cancelled. The main formula is 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. If n number of resistors are connected in parallel combination, if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, that is Rp equal to R by n. So this is very, very important. So remember this point. 1 by Rp, if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, Rp equal to R by n. I hope it is very clear to you all. Okay, once again, here current is different, right? So through R1, I1, through R2, I2, through R3, I3. Current is different, that's why. So current in parallel combination, IP equal to I1 equal to I1 plus I2 plus I3, V by Rp equal to V by R1 plus V by R2 plus V by R3. VB get cancelled, 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the formula, right? Yes. So I hope it is very clear to all. And if n number of resistors are connected, 1 by Rp equal to n by R, Rp equal to R by n. Okay, done. Now we will discuss about heating effect of electric current. So heating effect of electric current, that is nothing but the source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated entirely in the form of heat is known as heating effect of electric current. Okay. So heating effect of electric current is also known as Joule's law of heating. Joule's law of heating. So V equal to W by Q. W equal to V into Q. So P equal to W by T. VQ by T. So P equal to, so we know Q by T is I. Q by T is I. Yes or no? V equal to W by Q. V equal to W by Q. W equal to, so W cross multiply V into Q. P equal to W by T. P equal to W by T. VQ by T. So Q by T is I. Q by T is I. Now, so V into I. Energy is given to the conductor, that is equal to P into T. We know P into T. So whatever the heat energy is given, that will become in the form of heat. So Vi into T. So we know V equal to IR. V equal to IR. V equal to IR. V equal to IR. Now H equal to IR into I into T. Then we'll get H equal to I square RT. H equal to I square RT. So this is the formula, very very important. Very very important. This is about heating effect of electric current. Heating effect of electric current. So V equal to W by Q, W equal to VQ, P into rate of doing work, rate of electrical work. So VQ by T, so Q by T is I, P into VK, so whatever the energy is given to the conductor, so P into T, so we know that will convert whatever the energy is given to the conductor, that will become in the form of heat. So H equal to VA into T, V equal to IR, H equal to IR into IT, so H equal to I square RT. Short circuit, the direct contact of live wire in neutral wire takes place, then heavy amount of current will be drawn from the mains. Okay, so it may leads fire in the building. So that is short circuit. Overloading high voltage appliances on at a time, then heavy amount of current will be drawn from the mains. Still again same. And commercial unit of energy is kilowatt hour. 1 kilowatt hour equal to, so that is very very important. Just focus on it. 1 kilowatt hour, right? So let me know those who know the answer in the comment section. So homework, right? So I'll give as a homework this question. Try to identify 1 kilowatt hour, how much? So commercial unit of energy is kilowatt hour, right? So that's enough. So this is about heating effect of electric current and short circuit and overloading. I hope it is very clear. So thank you so much for joining and attending and listening to the class. So this is your Shiva sir from Student Brand. So if you like the content, please do like, share and subscribe to Student Brand. So if you have any doubts, you can ask in the comment section. So this is your Shiva sir from Student Brand signing off. Thank you.